So back to it. Let's check these out. Find dy over dx. By implicit differentiation, we've got 3y cubed plus xy equals 12. And e to the 2x over y equals x minus y. Really getting into some serious implicit equations here. Let's go for it. Find dy over dx. Okay, part A, 3y cubed plus xy equals 12. All right, I'll begin by taking the derivative of both sides with respect to x, and I like to slow myself down and just write this out right here. So the d over dx applied to the left, d over dx applied to the right, the derivative of what follows with respect to x, like that. Okay, now I'm going to think, all right. Looking at each term, well, let's see, this first one, that's got a y, so I know I'm going to take the derivative as normal, but then, because there's a chain rule, I'm going to multiply the whole thing by dy over dx. Okay, I can do that. Let's go for it. Let's see, 3y cubed, so that's going to be 9y squared, but then the derivative of the y, dy over dx. Okay, very nice. Plus, moving on, xy. All right, here's where we really got to be on our game. X times y is a product. We're multiplying two variables, so we have to apply the product rule here. That is so easy to miss, especially when you're first learning this new idea that implicit differentiation. You're so focused on make sure I take the the derivative of y, and I'm just wrestling with that, and you might miss something like that. This is a product rule. So let's point that out. We're multiplying two things, right? Again, like slow it down, kind of look carefully at each piece, which derivative rule applies here. And then when you execute those derivatives, am I taking the derivative of y, right? And so on. Okay, so for this product rule, I'm going to take the derivative of x. That's 1. Multiply it by the y, just copying that second part. That's the first half. Plus the x gets copied. Multiply it by the derivative of y. The derivative of y is dy over dx, derivative of y with respect to x. So there's that whole thing is our product rule. And it is equal to, we have a constant again. Not all problems are going to have a constant on the side, on the right side. But here it is. We got it another time. So that derivative, of course, is 0. Let's clean this up just a little bit. 9y squared dy over dx plus y plus x dy over dx equals 0. Okay. We have taken the derivative of both sides with respect to x. Now we will solve for dy over dx. Notice this time we have 2 of them. All right, so the dy over dx, that entire thing simply acts like a new variable. Right? This is telling us the derivative, it's the derivative we're looking for. So here's what we're going to do. We're going to keep these dy over dx terms on the left. We're going to move any terms that don't have dy over dx to the other side. Keep these here, move, subtract this y over there. Why are we doing that? So now these two terms, we can factor out the dy over dx. Why would we want to factor it? Well, now we can divide by what's in these parentheses, and we got it. Negative y over 9y squared plus x. There it is. Pretty cool. I'd also encourage you, go back and maybe even like graph the original function. Just see what it looks like. Let me jump on here. You know, we didn't like find an equation of a tangent line or anything like that, but it's kind of interesting to take a look at these. All right, you can just type it in right like that. Desmos can graph implicit equations. 3y cubed plus xy equals 12. Anything? Okay. All right, that's kind of nifty. So it's got this upper part, which sort of goes down. It looks like it has this horizontal asymptote at 0 eventually. And then it has this almost this kind of interesting shape looping around underneath there. Kind of cool. So if we wanted to know the slope of the tangent line at any point, we could plug in its x and y coordinates into our derivative. And we could find slopes of tangent lines, equations of tangent lines, all that. We're not going to do that here. We're just going to move on to part B. We have e to the 2x over y, wow, equals x minus y. Okay, now we have some variables on both sides. Taking the derivative of the left equals the derivative of the right. Let's see. The right side here is fairly tame. The left side, okay, wow. So as I look at this, I see there's a chain rule, right? I've got e raised to a power. So this is inside the e. And what's inside there is a quotient. So within that chain rule, I'll have a quotient rule. And of course, we got derivatives of y's happening. Okay, great. So on the left, the e is our outside. So the derivative of the outside here, I'm just going to copy everything, e to the 2x over y. That gets multiplied by the derivative of 2x over y. There I need quotient rule. Really, you know, because of the kind of the building nature of these derivative rules, we're constantly getting that practice. Okay, so quotient rule here is low times d high, well, derivative of 2x is 2, low d high minus high 2x, d low. The low is the y, so the derivative of y, dy over dx. Low d high minus high d low, all over the low squared, y squared. There's our quotient rule. Oh, wow. Just go one little piece at a time. Don't rush. You know, and kind of look back. Yep. You know, I kind of kept checking it, right? Okay, equals. On the right, derivative of x is 1 minus derivative of y, dy over dx. Okay. Aha. Well, this is a mess. Again, I see 2 dy over dx's. And we're got to solve for that. Oh man, so we've got this denominator, the e, wow. Let's do this. I'm going to multiply both sides by y squared. Just get rid of this thing. So I'll have e to the 2x over y times 2y minus 2x dy over dx equals y squared minus y squared dy over dx. I'll just distribute that y squared over on the right. I also want to distribute the e, right? I want to multiply everything out because I want to get my dy over dx terms on the same side and anything that's not a dy over dx term on the other side. So I got to just distribute here. Okay. So now I see my 2 dy over dx terms, and I see 2 non dy over dx terms. What I'm going to do I could, kind of go about this one of two ways. I'm going to add this one over to the left, and I'm going to take this term and subtract it. Okay, so if I add this over, I'm going to put it in front, y squared dy over dx minus 2x e to the 2x over y dy over dx. And I'm going to subtract this in the same step. And okay, so this got added over here, this stayed, this got subtracted. All right. Now we're looking really good. I can factor out my dy over dx and divide by what's left. And I'll be in a good spot. This just stays the same here on the right. And finally, dividing dy over dx. Whew, y squared minus 2y e, 2x over y, over all that y squared minus 2x e to the 2x over y. Notice like that symmetry. They're identical except for the x and y. Wow. It's kind of interesting. Would not have expected that. So there's our answer right there. Kind of cool. Okay, before we stop with this example, I want to explore one point. It turns out this original implicit equation passes through 0, -1. What is the slope of the tangent line at 0, -1? Let's kind of practice something. And I want to show you a little shortcut kind of while we're at it, depending on what question gets asked exactly. So if they ask for the slope of the tangent line here, well, we could certainly find dy over dx, and we could plug in 0 for x, -1 for y. If we do that, let me write it out over here. Dy over dx would equal, save this space. Let's see. So x is 0, y is -1. So we'd have -1 squared. Well, that's +1. -2 times -1 is +2. And then check this out. E, well, if x is 0, then this whole thing is e to the 0. And you might remember e to the 0 equals 1. Anything to the 0 equals 1. Okay, then the denominator is -1 squared, so that's 1 minus 2. The x is 0, so all that is gone. What would this work out to be? 1 plus 2 over 1, that would be a slope of 3. Okay, so that's perfectly fine. We plug everything in, and we get the slope of the tangent line there at 0, -1 to equal 3. Okay, what am I really getting at here? If the question says to find dy over dx, then this is how we do it. We got to take a very careful derivative and then very careful algebra, factoring all the way down to here. But if the question, say, maybe all the question asks is to find the slope of the tangent line, or maybe to find the equation of the tangent line at a certain point, would we need to go through all of these algebra steps to simplify dy over dx? No, you don't have to. If all the question asks is what's, say, the slope of the tangent line at a point, you'll need the derivative, of course. But if you want, you can just plug in your x and y values directly into this without simplifying first. That might be a lot easier because once you plug in all your x's and your y's, you're still going to have a dy over dx on this side and this side, but then you can solve it much faster because you'll only be working with numbers at that point. Let's try it that way. Let me copy this derivative that we found a moment ago, just the raw derivative. like that. If they don't ask for this, if they just say, hey, what's the slope here? Just say, all right, well, I found the derivative. Now I can plug in. So I'd have e to the 2x over y, but x is 0, so that'd be e to the 0. -1 times -2, excuse me, -1 times 2 is -2, minus 2, the x is 0. All of this is gone. Oh, wow, that just even wiped out that dy over dx. Over y squared, which is 1, and it equals 1 minus, nothing to plug in on this side, like that. That I could finish this up right over here. So let's see what would happen. E to the 0 is 1, so this would be -2 equals 1 minus dy over dx. I could add the dy over dx onto the left, add the 2 here, and dy over dx would equal 3. And that would get me to an answer much, much faster than if I went through all these steps of algebra. And it would avoid not only faster, but I could avoid a lot of potential for little mistakes along the way. Now, if the question says, to find dy over dx, then there's no way around it. Like, we got to do all this. We got to solve that in terms of x and y. But if all you need is the slope of the line, slope of the tangent line, boom, just plug right into that raw form, and there you go. I just want to graph this one real fast. It's got kind of a cool graph. E raised to the 2x over y equals x minus y. It's kind of like this hook, which is interesting. And you notice, yeah, it passes right there, right through 0, -1. We didn't find the equation of the tangent line. It wouldn't be too hard to do so, but we can see how that might equal 3. Let's see, if we went up 3, 1, 2, 3, and over 1, it would pass through this point here as well. Or even with those little boxes, it would go up 3 over 1, it would pass through right there. Yeah, I can see that. Okay, very cool. Let's stop this video here. More to come.